Okay, thank you. I'm sorry for the delay. I will start quickly so that we can go through this lecture. If you are attended the Congress regularly, then you would have seen this, that there are many talks about anonymizing systems were held here. So, for instance, yesterday we had a talk about Tor, and from Len Sasserman a talk about the Pynchon Gate. And in several previous years, there were talks about Tor by Roger Dingledine. We had talks here about Mix Minion, Mix Master, and I guess also about Chubb and John Doe. And if you follow the development in this section, the research, you may know that there are several other protocols like Tarzan or Morphmix or some other things. But one anonymizing network, which has also users, which has a practical side, was not introduced yet. This is I2P, and I want to introduce you I2P in my following lecture. So the structure is following that I will give you just a short overview. Then we look a bit in detail. We look what functionality there is in I2P, how is our messages sent there, and what ways are there to attack I2P, where are maybe flaws. And at the end, I will show some applications, but you saw that I had to change the laptop, and I don't know if I will go to the whole installation procedure and everything. Maybe I just will tell a little bit in the theory about it. Sorry for that. So just overview. I2P is obviously an anonymizing network. I just said that. It's the development of the network started in February 2003. It was first called, in the early days, it has several names, and then they called it Invisible Internet Project. And there comes also the name I2P, Invisible Internet Project. And yeah, actually we are at the version 0.6.1.30, and you will read everywhere that this is not, could not provide real anonymity like you read it in Tor, because the full feature set of is built in the version 1.0. So there are in every new version there come new sorry. There will come new features in the software, and so there on the website you find a roadmap what they plan to build in the software in the next days. Interesting, the I2P network or the software itself is developed by anonymous persons. So if you know a Tor network, there you have the Roger Dingledine, which who has made some talks here. There is Nick Matheson and other. Normally, you know these guys, and here the developers of I2P go another way. They stay anonymous, and you only know their nicknames. So I2P is a complete message-based network, and different from Tor, it offers you end-to-end encryption. Maybe when you follow the development in Tor, you will have noticed this year about this attack, or no, it's not real attack, but there was a large news that I guess it was a guy from Sweden. He set up several Tor nodes and sniffed passwords. And I guess 100 passwords he made public. It was some diplomatic login sites or so. And this can't happen with I2P because the messages inside the network are encrypted from Alice to Bob. So there's no exit node who can sniff all traffic. You just see all is encrypted there. So in I2P, is the protocol itself is a little bit complex, and I introduced here several terminologies, several words, and I will in the following explain some of the terms which are used here. You can read here the router, tunnel, gateway, and so on. So the simplest part is a router in the network. A router is just a normal PC with I2P software installed on it, and that's all. So there's nothing special about it. And the special thing in I2P is the so-called tunnel. Tunnels are unidirectional paths through several routers. So when you start your I2P software, it builds an inbound and an outbound tunnel. So, and if you, for instance, click on a web page, then the request for the web page will go through the outbound tunnel, and at some point the web page answers this request, and this comes back through the inbound tunnel. So that's a little bit different from other protocols you may know. And every router has several inbound and outbound connections, so several inbound and outbound tunnels. And each of the tunnel consists of several routers. So, and what you may know, or what is similar to other protocols, that those tunnels use layered encryption. It's like the ideas from Chom, and I made here a little graphic which shows a router with just one outbound tunnel, and those tunnels are split or in several parts. The first part is the so-called tunnel gateway. The tunnel gateway is the first router in a tunnel. So if we look back here, the router with the name A there, this is in that case of the outbound tunnel, the gateway. And if you have an inbound tunnel, which comes back, so which comes from the outside to your computer, this would be the last hop of your tunnel. So the gateway is the node A or the last node, depending if you have an inbound or an outbound tunnel. And the gateway does several things. If it is an outbound tunnel, or I started with an inbound tunnel. So if it is an inbound tunnel, it receives messages from any peers, collects them, and forwards them along the tunnel until it comes to, in that case, to my router, and my router then decrypts all and shows me the message or whatever it does. And in case of an outbound tunnel, it does some pre-processing on the messages, encodes them, and sends them also along the way through the different routers in the tunnel. Another important point is the tunnel endpoint. There are like tunnel gateways to different endpoints. In the case of an outbound tunnel, here it would be the node C, the last point of the tunnel. And if you have an inbound tunnel, then it's the other one, the creator of the tunnel. So, and the specific thing here is that the endpoint of the tunnel is not necessarily the endpoint of the communication. In the further designs, or in the end design of I2P, the endpoint of one tunnel can choose just another tunnel which routes the message along, and the next endpoint then, for instance, sends the message through the receiver of the message. So, but at the moment, the endpoint of the tunnel is the endpoint of the communication. That's the actual point, but in future this will change. And one of the key concepts of the I2P is the network database. So normally your router should know about where to send those messages, should know about the tunnels and so on. And all those informations are stored in the so-called network database, or the short version is netDb. And the netDB is just a pair of algorithms which share those network metadata. And main part of it is, or the main algorithm is a distributed hash table. It's called Kademlia. And well, I2P doesn't use the Kademlia itself, but a derived version from it. And the second algorithm is for bootstrapping the network. They use some floodfill peers, and they are by definition always the nearest nodes. And this Kademlia algorithm just measures distances between different nodes. And if you look at normal network measurement distances, you will see that they use they count the number of hops which a message needs, or they count the round trip time, or so on. And Kademlia goes in another way. They set to every router a specific node ID. It's a, I guess, 160 bits long identifier. And when they measure the distance between two hops, they XOR the node IDs. And in the paper of the algorithm, they prove that XORing is a valid distance measure, and so they use it here in I2P too. And coming back to the network database, every router maintains its own network database. So it's not like in Tor that there is a central database, like this, in Tor they call it directory servers. Here, every router maintains its own database. And that's why you will often hear that I2P follows this peer-to-peer approach, and that's really true, that the whole network is really decentralized and there's no central information, so on. So, and the network database itself contains two types of metadata. One is the lease set, and another one is the router info. The following I'll describe shortly what it is. The router info is metadata which is used to contact another router, and it contains several things. First of all, the router's identity. There is a 2048-bit El-Gamal encryption key, plus a 1024-bit DSA signing key, plus a certificate, which is all the router's identity. Then you have a contact address, and this is normally the IP address of the server plus the port where you can reach this thing. When this router publishes its information, so in the web interface, you see it 40 hours ago or 23 minutes ago or such things. And in the router info itself, there is a date field. And last is a set of text options, just normal text. There is no real use in the version 1.0. At the moment, it is used just for debugging. So they try to analyze the network and measure several things. And if you think this will reduce your anonymity, you can just disable this with a specific option. Yeah, and in the end version, it will also disabled as in the version 1.0. So, and all those data are signed. So the last one is a signature of all the data. And that's the thing you will see throughout the whole network. Every message is signed in several ways. So this whole network database thing is self-authenticating. The second thing is the lease set. And the lease set contains a group of tunnel gateways. So like I said in the beginning, every router builds several tunnels, inbound and outbound. And in the lease set, there you find the gateway of the inbound tunnels. Furthermore, a 4-byte tunnel ID and an expiry date of that specific tunnel. Interesting, every tunnel is built every 10 minutes. It's like in Tor. Tor also says that they build new routes through the network every 10 minutes, and it's the same like here in I2P, that every 10 minutes is a new tunnel built. And in the lease set, you find the expiry date, and then you can just choose if it's appropriate to use that tunnel or if it's invalid in 2 seconds or so. And also there are additional pairs of encryption and signing keys which are in this thing. And also it's just a signature. So those two informations you find in the network database. So, and I said I2P is a decentralized network. The network database is also a decentralized database, so you can't just fetch the actual version of the network from some server. So you have to do some bootstrapping in the beginning. And I just told that there are some floodfill peers that come with I2P. And these are some specific server which are by definition nodes which are which have a very short distance. And your router then requests the router info of one of those peers. And if it gets this, it queries this router for references to other routers. So it starts by choosing one router, and it asks for reference. It asks this router for references to other routers, and then goes to the other routers, asks them for references, and so it tries to build the whole database. And also, when your network database is up, it makes in regularly in intervals testing of tunnels. It just looks if there is capacity on that specific tunnel. If it maybe can choose another one, I will tell that a bit later. And the last one is this so-called garlic routing. In the traditional protocols, you have this onion routing where you choose your end node take that key, encrypt your message with the key to of this end node, then look for the previous node, that encrypt your message with the key of the previous node, and so on and so on. And if you send the message along the way, the first router in your circuit will unwrap the outer onion layer and send it to the next, and so on and so on. And this is normally called onion routing. And I2P has introduced the garlic routing. And here is so that the basic principle is like the onion routing, but they take several messages into one garlic and do also encryption, send them along your outbound tunnel, and the gateway, the tunnel gateway of the outbound tunnel, then can decrypt the outer layer of the garlic and has several, well, actually, I don't know the English word for this Knoblauchzehe. So let's say there are, out of the garlic come several onions, and then you have this onion router principle. So it's not really correct, but I hope you understand what I'm trying to tell you. So, and this is called, this principle is called garlic routing. So, and now that we know this, the basic terminology, we can have a look on how to send messages to other routers. So, when Alice wants a message, wants to send a message to Bob, she examines the following steps. First, she requests her network database for Bob's lease set. And hopefully she gets some information. Normally she will get back the inbound gateways plus the above mentioned information, so the keys and the expiry date and so on. And with that information, Alice can now choose an outbound tunnel. And I said it before, the I2P tests in regular intervals the network. They send test messages and measure how long this message goes along the tunnel, how much capacity the routers have, and store that information also in the network database. And normally they divide the routers in 4 categories. So the first one is fast and high capacity. The next one is fast. The third one is not failing, and the fourth one is failing. And at the moment, it is so that Alice will choose from the first category, from the fast and high capacity routers, and makes a tunnel through those routers. And in further development versions of I2P, it is planned to implement further strategies to choose routers and tunnels. When Alice has chosen this outbound tunnel, it gives this message to the tunnel gateway. The tunnel gateway encrypts the message, and adds some instruction on how to forward this specific message. Eventually, the gateway waits and collects several other messages, and then forwards them along the tunnel. So a tunnel consists of several routers, and at some point it reaches the endpoint, and the endpoint then encrypts the messages, gets those forwarding instructions, and from that instruction it gives the message to Bob's inbound tunnel gateway. And Bob's inbound tunnel gateway will take the message, does also some pre-processing, does some encryption on it, and forwards it then to Bob's router. And Bob's router decrypts all layers and will show then a web page or will do some other things. So that's the basic way on how a message goes through the I2P network. And
how does Alice know that she's talking to Bob?
the question is, how does Alice know that she is talking to Bob? Alice chooses by herself that she wants to talk to Bob, and Bob's identity is in the network database. It's there is the encryption key, several keys there, and so she can she for herself chooses the route to Bob. Okay. So and what happens when Bob wants to answer the message from Alice? Basically, it's the same like sending the message, except one thing. Alice sends within her message her destination. So Bob doesn't need to make a lookup in his network database. He just takes the destination out of the message and sends the message along his outbound tunnel, and then it reaches the endpoint, goes to the gateway, and then back to the inbound tunnel and to Alice. So that's the whole thing on how to send and answer messages within the gateway, within the I2P network. So what is the threat model? What possibilities to attack are there? I introduced here 4 different ways. You can imagine several other attacking ways. Also, the developers itself discuss several other maybe more exotic ways to attack the I2P network. I just concentrated on 4 widely available methods. So first is the so-called replay attack. So if there's an eavesdropper, like say Eve, it watches the network and watches what messages go through this network and takes one message out of the network and just resends that message again. That's basically the replay attack. So maybe someone of you is familiar with the cypherpunk remailers. There was this replay attack worked there. You could just take out one email, send it along the way, and if you do it 100 times, 1,000 times, you can then just see from what point to what point the message is sent. And so the replay attack is one of the attacks which you should have an eye on. And here with I2P, this replay attack won't work, and I guess with nearly all modern anonymous systems, this replay attack will not work because there are several messages assigned. They get several IDs underway, and the routers check if they have seen the message before, and when the message was seen before, it is just dropped. So a replay attack doesn't work here. Another powerful attack is the so-called tagging attack. Then you just watch the messages going along the network and do or tag a specific network, a specific message. So you make like a mark on that message, and the message goes along the way, and at some point you just look at all messages and watch if there is a message which come along with your mark. So that's basically the tagging attack. And with I2P, this is it's so that all messages are signed, and so if you do some tagging, if you change the content of the message, then the hash, the signature will change, and so the tagging attack basically also won't work. Another one is so-called Sybil attack. Sybil attack bases on the fact that you can install several routers. So if you have a network of, let's say, 100 routers, and you will have like a control over the network, you just install by yourself, let's say, 900 routers. So you have now a network of 1,000 routers, but 900 of them belong to the attacker. And then the attacker can mount several other attacks through his malicious nodes. And there are some ideas how to defeat this cyber attack. At the moment, there is no built-in solution with I2P, but maybe you remember I told that with the router info, the router identity has an encryption key, signature key, and a certificate. And this certificate should, in other versions, be a hash cache certificate. And this, so you have to, just, I have to drink. So this hash cache certificate, there you have to calculate and prove something, and it's very hard to install 900 routers like in my example. So, but in the moment the cyber attack will work, but in future versions there was some defeating against it. And the last one is like a DOS attack, flooding. You can flood the network, or flood specific routers, specific tunnels, etc. And depending what you are looking, this attack will work or will not work. So flooding the whole network will just basically work. If you take 10,000s of messages and inject them to the network, you can flood this network. But if you want to flood a specific tunnel, then this is more problematic, because the tunnel will measures the performance, and if there come too many messages in the tunnel, it just builds another tunnel and another tunnel and another tunnel. So the more messages come in, the more tunnels it will build. So there's basically some defeat against that attack. And like I said, there are many more attacks available. Some work not. And if you're interested in there, just have a look at the documents at the website. Yes?
At the beginning of the connection, Alice is asking for Bob's DB.
Yeah?
Repeat
the
question, please.
Yeah. So his question was, at the beginning of the connection, Alice is looking at the netDB for the least set of Bob, and is there a possibility to sniff this connection? So the network database sits on the local computer, on your local router. So there's no, if you can sniff this connection, you have to sit on your computer. Or do I misunderstand you? So basically there is no way to sniff. Yes, and the last.
Excuse me. Another question. Did I get it right that Alice wants to talk to Bob, and Alice knows Bob, and Bob knows that Alice wants to talk to him, right? Don't escape. So Alice wants to talk to Bob.
Yeah.
Alice knows she wants to who Bob is, and Bob knows that Alice wants to talk to her, to him. Well, who knows? But did I get this right?
So, I'm not quite sure what you're trying to say.
Okay.
So Alice knows that she will talk to Bob.
Yeah. No, so far, I mean, I understand that's quite well encrypted, but
yeah.
I'm not getting the point of how it is anonymous. Because Alice knows Bob because she asks for Bob, so probably she will get the connection to Bob. So yeah, so maybe you could say something about this. Anonymous would mean that Bob doesn't know who he's talking to.
He only knows the router.
Yeah.
If Bob searches for Alice, then he only gets back the routers.
So his question was so Alice knows Bob's identity, like he looks in the database, and so maybe Bob also knows who Alice is. Is that correct?
Yeah.
Or what are you trying to say exactly?
I think he there's a misunderstanding because if Bob wants to talk to Alice, or the other way around, doesn't matter. If Bob wants to talk to Alice, he doesn't have to know the IP of Alice or something. He just looks up in his own net database and then finds the gateways to the inbound gateways of Alice. So then he will send a message to to one of those gateways, and those gateways then have a tunnel to Alice. So he has no direct connection or no possibility to directly connect to Alice. At least that's how I understood it.
Yeah, that's correct.
Okay.
Okay. Yeah, and are there other questions? Oh, so and the last thing which I wanted to show you are some applications. I2P has with I2P you can use several things. One thing is email. So I will just go through these points in theory, but because otherwise I had to install I2P on that computer and so on. I guess that this will last too long. So I'm sorry that my computer wouldn't work. So email, you get or you can choose a name like anonymous at mail.i2p. There's a central site, the hq.postman.i2p. There you can register your name and password. And then you have the possibility to just set up a normal mail client like Thunderbird, Mood, or whatever. And this mail client will communicate with your local I2P router, with a local I2P client, and send then your mails out of the network. So, and with email, you just can't send emails within the I2P network. You can also send emails out of the I2P network and receive emails from the outside world. And every email address at the moment is some name at mail.i2p. And another version is web interface. You have just a web mailer where you log in and can send your messages, read your messages, and so on. The next thing is IRC. So when you install the I2P client, run that I2P client, you have the possibility to connect to it anonymously to IRC and chat there with normal chat clients like don't know, IRC or a pigeon or whatever there is. A nice thing which the I2P offers you are the so-called EAP sites. This is basically a normal website. You can anonymously publish on your website some things. So with the I2P distribution, there comes a web server, and you can just put in HTML files and CSS files and so on within that network, within this directory, and other users can surf to that page. And the normal way is that you choose a name, let's say 24c3.i2p, register that name, and then you have a local directory. Under the I2P directory, there is eap site/.root, and with all the data which are in that directory, well, you can publish via a website. So that's one way to get such an eap site, or you can install an Apache or Lite or something else and let this Apache deliver the websites. And this eap sites is a very nice way to have, publish anonymously some things. And the fourth thing is anonymous file sharing. So with I2P, there come several clients for BitTorrent. There's a Azureus client, and I guess Emule, and some other. And so you can make their file sharing whatever you want. And the last point, which I forgot to mention here, is there is also a built-in blogging tool called Cindy. So there you can blog if you want anonymously, or can post into a forum, read anonymously forum postings, or write forum postings, and so on. So there are different ways, and several developers sit there and try to build new applications and makes it more usable. So,
got another question about the anonymous part. I mean, one of the more important parts of such an anonymizing network is that although Alice and Bob can talk to each other, it's important that both Alice does not know who Bob really is, who the real person behind the node known as Bob is, and that Bob, vice versa, doesn't know who Alice really is. How do you... but then there are, you're usually using I2P as a tunnel for more or less traditional applications. How do you defend against things like traffic fingerprinting? For example, somebody uses a Lite server for his eap site, and this always identifies it as a Lite server. And if you dig around it a little, you find out there are only very few people who actually use Lite and I2P. Or another thing, you monitor when a certain eap site is down and when it is up, and then you can also monitor what hosts are up and down at which times.
Okay. Those are two good points. The first was if you run a Lite HTTP web server, this web server sends some sensitive information.
Same goes for the browser.
Yeah.
Same goes for the browser on the client side.
And then you can maybe de-anonymize that guy, and well, that's really a setup thing. So you have to set up your Lite web server correct, or your Apache web server correct, that it doesn't send out those sensitive information. Or you just use this built-in eap site thing, and then hopefully this sensitive information won't get out. But the same problem you have with this Tor hidden services, it's the same. That you have also to set up the Apache correct, that it doesn't provide too much sensitive information. And the second point which you said is that you monitor a specific EAP site when it's up and when it's down. So like say I run my EAP site on my local laptop here, and now I have network here at the 24C3 and just start my I2P, then my EAP site is on, then tomorrow, today in the evening, I just go home, switch it off, and it's off. And if I do this for some days, I can see when the user is up and when he sleeps and so on. And then with some statistics, I can maybe de-anonymize him. And that's also a problem, not a problem of I2P, it's more a problem of the user. So if you run such an EAP site, you have to be aware that this thing can happen, and it's better to run that EAP site on a server which is always on, or which is, yeah, the best thing is that it's always on. There, here in front was another question.
Are there I2P to World Wide Web gateways, or is this something that will be implemented, or is it just a network of its own? Or with other words, can it be an alternative to other things like Tor to serve within the web, the normal web, or will it always be, or is it planned to keep it a communication network basically like it is?
There is still, or at the moment, a proxy. You just start your I2P client, set your browser to port 4444, and there you have an so HTTP proxy, localhost port 4444, and then you have a gateway to the normal web. So yes, there it is. But if you go out from the I2P to the normal network, you have the normal problems which you with Tor at the moment. No? Yeah. Okay, next question.
Okay, I originally wanted to ask if you're through with your slides, because we are already starting with the question and answering, but since the slides are off now, I wanted to ask, since you don't have a central server for the hash table, you said that you rely on some kind of file or some initial servers that will then distribute the hash table. So when I first connect with my I2P client, I will get a fresh list of other I2P clients. What now if we imagine from the point of view of China or some other restrictive regime, that we just know, because we can just download a new I2P client so we get this list. What if we just set our firewalls to look which clients from China are connecting to these IPs? Because then we would, without a problem, just get a list of people who are using I2P and, well, could therefore de-anonymize them. Is there any protection against this?
Well, the fact that you use I2P, that you can't hide at the moment. And as far as I know, it's not planned to build in such a feature that you hide the fact that you use I2P. So if you install I2P on your computer and use it, your, let's say, ISP can see that you use I2P and can selectively block you. Okay, are there other questions?
Can you make a brief comparison between I2P and QNet?
The question was if I can make a comparison between I2P and QNet. Yeah. No, sorry. But if you look at the web page, there are comparisons to several networks, so I2P and Tor, I2P and Mixmaster, and I guess also I2P and QNet. So just go to www.i2p.net. Okay, I just got the finishing line. So thank you for listening to me and have a nice day.